Hi everyone, in this video we're going to look at solving simple exponential and logarithmic equations. Now when we look at these examples, it can be helpful to apply log rules. For example, in our first question here, we have 5 to the power of x minus 1 is equal to 2. We'll see right away that there is an advantage to taking the log of both sides. So think about this. If you take the log of both sides, you now can apply the power rule and take this exponent and bring it out in front. So it is much easier to solve for x once we do this. We get x minus 1 times log of 5 is equal to log of 2. Now think about how you want to solve for x. Right now, x minus 1 is being multiplied by log of 5, so I'm going to go ahead and divide both sides by log of 5 to get log of 2 divided by log of 5. Then to get x by itself, all I need to do is add 1 to both sides of the equation. So we know that x, and this is x in its exact form, is equal to log of 2 divided by log of 5 plus 1. So you can leave it like that if you want to keep it in its exact form, or we can estimate it as a decimal, and if we do that, we get x is equal to approximately 1.43. Let's look at another example of this. So in this case, same thing. We know we are dealing with an exponent, which means we are going to need to take the log of both sides. So taking the log of the right side, we get log of 2 times 10 x plus 2 is equal to log of 35. Now the first thing we're going to do is apply the product rule. We're going to do that to separate this into two different logs. So we have log of 2 plus log of 10 to the power of x plus 2 is equal to log of 35. Then we want to work on getting x by itself. The first thing we're going to do is subtract log of 2 from both sides of the equation to give us log of 10 x plus 2 is equal to log of 35 minus log of 2. Then we're able to take this exponent and use the power rule to bring it out in front. So that means that this will then be equal to x plus 2 multiplied by log 10 is equal to log 35 minus log of 2. And then to get x plus 2 by itself, we're going to divide both sides by log 10, giving us x plus 2 is equal to log of 35 minus log of 2 divided by log of 10. And finally, we can subtract 2 from both sides, giving us a final answer of x is equal to log of 35 minus log of 2 over log of 10 minus 2. Let's look at another question. This time we're going to start with a log already there. So in this question, we have 3 log 2x minus 1 is equal to 1. We're going to solve this one a little bit differently. So I'm going to start by just getting the log by itself by dividing both sides by 3. So we get log of 2x minus 1 is equal to 1 over 3. Now let's think about switching this from log to exponential form. If we do that, we get, and remember, the base, if you don't see it, is a 10. We're going to get 10 to the power of 1 over 3 is equal to 2x minus 1. Now we can work on solving for x. So to do that, we're going to add 1 to both sides. I'm also going to rewrite the 10 to the power of 1 over 3 as a cubed root of 10. We're adding 1 to that, and that is equal to 2x, which means that x in this case would just be equal to the cubed root of 10 plus 1 divided by 2. Okay, last example then. In this case, we have log of 2x minus 1 plus log of x plus 4 is equal to 1. So the first thing we're going to do in this question is figure out what to do with this 1, because we have 2 logs on the other side, but no log on the right side. Now, if you want to replace the 1, all you have to do is replace it with log of your base. So in this case, you don't see a base, which means the base is 10. And log 10 is equal to 1. So we're going to start by rewriting this as log of 2x minus 1 plus log of x plus 4 is equal to log of 10. Now we can apply the product rule to the left side. When we do that, we get log of 2x minus 1 times x plus 4 is equal to log of 10. We now have logs on both sides, which means we can just get rid of them. Log of whatever is in this bracket has to be equal to 10. So on our next step, we're turning this into 2x minus 1 times x plus 4 is equal to 10. Now we have a quadratic equation. So expanding this fully, we're just going to FOIL absolutely everything through. And when we do that, we're going to get 2x squared plus 8x minus x minus 4 is equal to 10. Bringing the 10 over to the other side and combining like terms, we get 2x squared plus 7x minus 4 minus 10 is equal to 0, or 2x squared plus 7x minus 14 is equal to 0. So let's solve this by putting it into the quadratic equation. We know that a would be equal to 2, b is equal to 7, and c is equal to negative 14. The quadratic equation tells us that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Plugging in what we have, we get x is equal to negative 7 plus or minus the square root of 7 squared minus 4 times 2 times negative 14, all divided by 2 times 2. Let's simplify this a little bit more. I'm just going to simplify everything that's under the square root sign, giving us negative 7 plus or minus the square root of 161 over 4. And that is going to be our answer. So technically we have two answers for x that could work here. It is x is equal to negative 7 plus the square root of 161 over 4, and x is equal to negative 7 minus the square root of 161 over 4. I'm going to approximate these as decimals as well. So the first one is going to work out to 1.42 approximately. And the second one will work out to negative 4.92. Now remember, you can't take the log of a negative So we want to scroll up and look at our original question and see if either of those answers would result in a negative. If you were to plug in the negative number, so the negative 4.92, it would turn into a negative log in both of these brackets, which means that that one is an invalid answer. So we're going to not include that as an answer, and our final answer will just be the 1.42.